Deep in the vast darkness of space, a single catalogue holds some of the universe's most bizarre secrets. The new General Catalogue, or NGC, is far more than a simple list of celestial objects. It is a collection of cosmic anomalies that defy logic and challenge our most fundamental ideas. By the end of this journey, you will have explored 28 of the strangest objects in the known universe, from colliding galaxies to dying stars that create perfect rings. Why does one nebula appear to blink in and out of existence, and what force could carve a truly empty hole in the heart of a glowing gas cloud? What does it feel like to witness a mystery that has no easy answer? A chaotic swirl of light, NGC 520, is a portrait of pure destruction and creation. This is not a single galaxy, but two colossal star systems violently merging in a process that takes hundreds of millions of years. Enormous tidal tails, streams of billions of stars, are being violently ripped from their galactic homes and flung into the intergalactic void. This cosmic car crash compresses vast clouds of gas and dust, triggering a ferocious firestorm of new star birth. The entire object glows with the intense light of these newborn stars, a brilliant but temporary blaze ignited by the chaos. Its shape is bizarre and utterly irregular, a far cry from the neat spirals or smooth ellipses we often associate with galaxies. This tangled mess is a rare, real-time look at galactic evolution, a strange and spectacular sight that reveals how the universe constantly remakes itself through colossal acts of violence. This violent merger is far more than a spectacle. It is a preview of a final cosmic state. After hundreds of millions of years of chaos, the two spiral galaxies in NGC 520 will finally settle. Their distinctive shapes, the elegant arms and bright cores, will be completely erased. What will emerge from the wreckage is something entirely new and far simpler, a gigantic elliptical galaxy. This final form is a smooth, featureless sphere of ancient stars, a quiet retirement home for solar systems after the ferocious bursts of star birth have consumed all the available gas. And what of the monsters at the heart of this chaos? Each of the original galaxies almost certainly contained a supermassive black hole. As the galaxies spiral together, these two gravitational titans will also be drawn into a fatal dance. They will sink towards the new galactic center, orbiting each other until they finally merge into a single, even more colossal black hole, an event that will shake the very fabric of space-time with gravitational waves. This entire process is a cosmic blueprint, one that directly involves us. Our own Milky Way galaxy and the great Andromeda galaxy are on a collision course. In about 4 billion years, they too will begin a long, slow dance of destruction and creation that will look remarkably similar to NGC 520. The familiar starry band of our Milky Way will be utterly transformed, eventually replaced by a single, giant elliptical galaxy that future inhabitants of our solar system, should any remain, would call home. We are not just watching a distant collision, we are seeing the inevitable future of our own galactic neighborhood. Yet from the wreckage of colliding galaxies, we find another cosmic anomaly, one that clings to existence against all odds. NGC 1275 is the monstrous heart of the Perseus Cluster, a giant elliptical galaxy that reigns over a family of thousands of galaxies. But its true strangeness is not its size, but the delicate threads that surround it. Stretching for thousands of light years from its core are vast, filamentary structures of cool gas glowing with an eerie red light. These cosmic cobwebs drift through a space that should tear them apart in an instant. The entire galaxy is immersed in a superheated plasma, the intracluster medium, which is so hot it should evaporate these cold filaments in a cosmic blink. Yet they persist, defying the destructive heat for hundreds of millions of years. The secret to their survival is a cosmic scaffold of immense power. Intricate magnetic fields generated by the violent motions within the cluster weave through these gas threads. This magnetic skeleton holds the delicate structures together, providing a supporting framework that prevents the surrounding inferno from dissolving them. It is like a fragile web of ice miraculously holding its shape in the heart of a blast furnace. But what force could create such a bizarre and enduring structure? The answer lies in the galaxy's core, where a ravenous supermassive black hole is feeding. This active galactic nucleus unleashes titanic jets of energy and matter which churn the surrounding gas. This violent activity may well be the very source of the cool gas filaments, pulling material out from the galactic center and allowing it to condense into these long, mysterious threads. NGC 1275 presents us with a beautiful paradox, a delicate cosmic tapestry woven by the most violent processes in the universe, all held together by invisible magnetic threads. From delicate filaments held by magnetic threads, we turn to a galaxy that seems almost too perfect to be real. Hoag's object is a cosmic enigma, a stunningly beautiful ring of brilliant blue stars that forms a near-perfect circle around a golden, glowing core. Between this central hub and the outer ring lies a vast, dark gap that appears almost completely empty. It looks less like a naturally formed galaxy and more like a piece of celestial jewelry, a golden pearl set within a sapphire band. This is not the chaotic aftermath of a collision like NGC 520, nor is it a messy collection of filaments like NGC 1275. This is a structure of breathtaking symmetry, and its origin is one of astronomy's most charming puzzles. How does a galaxy decide to arrange itself with such geometric precision? The leading theory suggests a galactic collision, but one of a very specific and rare kind. Billions of years ago, a smaller galaxy may have plunged directly through the heart of what was then a normal spiral galaxy. The gravitational shockwave from this bullseye impact would have sent a ripple of dense gas and dust rushing outward from the center. This expanding wave then triggered a firestorm of new star formation, creating the brilliant blue ring we see today. The central core, left relatively undisturbed, continues to host its older yellow stars. The apparent emptiness between them is not truly empty. It is simply a region where stars are not forming and the gas has been either used up or pushed away. Another compelling idea points to an internal instability. Perhaps the galaxy's own core became unstable in its distant past, expelling its outer disk of gas in a massive outburst. This ejected material then coalesced into the perfect ring of stars, leaving the ancient core behind. Regardless of its true origin, Hoag's object remains profoundly isolated, with no obvious culprit for a collision anywhere near it. This isolation only deepens the mystery. It is a serene and photogenic paradox, a snapshot of a fleeting moment in cosmic evolution that seems to defy the violent chaos from which it may have been born. What other strange and beautiful shapes are hiding in the darkness, waiting to challenge our understanding? But perfect symmetry is not the universe's only rule. Drifting through the southern skies, NGC 2442 presents a dramatically different vision, a galaxy so distorted it has earned the name the Meathook. Its spiral arms are not elegant and balanced, but violently twisted into a shape that resembles a cosmic question mark. This bizarre form is a permanent scar, the result of a close gravitational encounter with another galaxy in the ancient past. That celestial flyby did not result in a full merger, but its gravitational pull was enough to violently wrench the galaxy's structure, pulling its arms out of their natural shape and leaving them frozen in this hooked configuration. The most striking evidence of this past trauma is the profound asymmetry of its two main arms. One arm is compact and tightly wound, a hive of frantic activity where intense pockets of pinkish glow betray the birth of new, massive stars. The other arm is long, stretched, and strangely quiet, a skeletal structure littered with the faint, expanding shells of ancient supernova remnants. These are the ghosts of stars that lived fast and died young, their explosive death seeding the galactic environment with heavy elements. The Meathook Galaxy is a frozen moment in time, a celestial fossil that tells the story of a near miss. It shows us that a galaxy's shape is not always a product of serene evolution, but can be permanently sculpted by a single, violent encounter, leaving one arm bustling with life and the other a monument to stellar death. Some galactic cores do not just glow, they stare back with an unsettling intensity. NGC 4151 has earned its dramatic nickname, the Eye of Sauron, for a chillingly good reason. At its heart lies a brilliant, ring-like structure, a searingly bright circle of hot gas surrounding a dark, central pupil. This is the signature of an active galactic nucleus, a region of space so energetic it outshines the rest of its own galaxy. The power source for this cosmic eye is a ravenous supermassive black hole, greedily feeding on any star or gas cloud that ventures too close. As this material spirals inward, it forms a superheated disk, an accretion disk that shines with the light of billions of stars. But the true strangeness of this particular eye is not just its intimidating gaze, but its unpredictable behavior. It blinks. Astronomers observing it in X-ray light have recorded its brightness changing dramatically over periods as short as a few hours. This is not the steady glow of a well-fed engine. It is the cosmic equivalent of a hiccup, a flickering that suggests the black hole's meal is being delivered in messy, chaotic bursts. What could possibly cause a supermassive black hole to eat in such a fitful, irregular way? One compelling theory points to a second, unseen monster lurking in the dark. The flickering could be the telltale sign of a binary black hole system, two gravitational titans locked in a tight orbital dance at the galaxy's core. As they circle one another, their complex gravitational fields would churn and disrupt the flow of incoming gas. One black hole might temporarily steal matter from the other, or their combined gravity could create chaotic eddies in the accretion disk, causing the brilliant light to stutter and surge. This celestial tug-of-war would create the erratic feeding patterns we observe, a flickering eye in the depths of space hinting at a hidden, dueling heart. It is a reminder that even the most terrifying cosmic structures can be governed by an unseen partner, a ghost in the machine whose presence is only revealed by a telltale, rhythmic hiccup in the light. While the Eye of Sauron blinks with unpredictable fury, another cosmic giant broadcasts its presence across the entire electromagnetic spectrum. NGC 5128, better known as Centaurus A, is the closest active radio galaxy to our own, a chaotic behemoth sitting just over 10 million light-years away. At first glance, it appears to be a simple elliptical galaxy, a fuzzy ball of ancient stars, but slicing directly across its center is a thick, dark, and strangely warped band of dust. This bizarre feature makes it look as if a cosmic painter took a clean brushstroke of black ink and smeared it across a golden canvas. This dramatic dust lane is the lingering scar of a galactic merger that occurred hundreds of millions of years ago. A small spiral galaxy, rich with gas and dust, was devoured by a much larger elliptical galaxy. The violent collision did not just stir the stars, it funneled enormous amounts of cold gas and dust directly toward the galaxy's core, feeding the sleeping monster that resided there. That monster is a supermassive black hole, and the feast it received awoke it with a vengeance. Now, this black hole is actively consuming material, and its influence is anything but subtle. From the polar regions of its accretion disk, it blasts out two colossal jets of superheated plasma. These jets, traveling at nearly the speed of light, stretch for over 1 million light-years into intergalactic space, far beyond the visible boundaries of the galaxy itself. When we observe Centaurus with radio telescopes, these jets are the most dominant feature in the sky, making it the fifth brightest radio source in the entire heavens. This makes Centaurus a perfect natural laboratory, a nearby example of the violent processes that shape galaxies across the cosmos. We can study its chaotic heart, its immense jets, and its warped dust lane in incredible detail, watching a supermassive black hole reshape its entire home galaxy long after the initial collision that triggered its awakening. It is a living testament to the enduring power of a single, violent event, a galactic drama that continues to unfold just next door. Yet the violence of galactic cores pales before the final, beautiful fury of a dying star. NGC 6302, known as the Bug Nebula, is the spectacular last gasp of a sun-like star, a cosmic butterfly frozen at the moment it burst from its stellar cocoon. Its shape is a perfect hourglass with two vast wings of glowing gas stretching over 3 light-years across. This incredible symmetry was not born from a gentle process but from a ferocious stellar wind. The dying star at its heart, now a white dwarf, expelled its outer layers in 2 powerful, opposing jets. These jets slammed into the slower-moving gas the star had shed earlier in its life, sculpting the material into these delicate, wing-like lobes. But the true strangeness of the Bug Nebula is hidden deep within its glowing body. The central star itself is one of the hottest objects ever discovered, with a surface temperature estimated to exceed 400,000 degrees Fahrenheit. This incredible heat is the fading afterglow of the star's final, violent convulsions, yet we cannot see this stellar corpse directly. It is shrouded in a thick, dark belt of dust and molecular material, a dense equatorial ring that we view almost perfectly edge-on. This ring acts like a cosmic corset, pinching the outflowing gas and forcing it into the distinct bipolar shape we observe. The chemical composition of the nebula reads like a complex organic recipe. Astronomers have detected vast clouds of water ice, carbon dioxide ice, and a rich cocktail of hydrocarbons frozen onto the dust grains. We are essentially looking at the raw ingredients for complex chemistry, the same kind of ices that coat comets in our own solar system, all forged in the intense heat and radiation of a stellar death. The Bug Nebula is more than a beautiful farewell. It is a cosmic factory, seeding the interstellar medium with the very building blocks of future worlds and perhaps one day life itself. Even a dying star can leave behind a masterpiece of cosmic complexity. NGC 6543, the Cat's Eye Nebula, stares back at us with an intricate structure that is both beautiful and bewildering. Unlike the relatively simple hourglass of the Bug Nebula, the Cat's Eye is a labyrinth of concentric gas shells like the layered skins of a cosmic onion. These delicate, perfectly spaced rings of glowing material expand outward from the central star, each one a fossilized record of a separate, violent outburst. It appears the star did not die in one single grand explosion, but in a series of powerful, periodic convulsions, puffing off its outer layers in rhythmic pulses separated by roughly 1,500 years. But the strangeness does not stop with these shells. Extending perpendicularly from the core are 2 immense, jet-like structures blasting outwards at incredible speeds. This combination of symmetrical shells and polar jets creates a pattern of breathtaking intricacy, a level of detail that defies a simple explanation for a solitary star's death. How could a single, dying star orchestrate such a complex and structured finale? The leading theory points to a hidden dance at the heart of the chaos. The central star, a fiercely hot white dwarf, might not be alone. It could be locked in a tight gravitational embrace with a companion star, a binary partner. As the primary star swelled into a red giant, its outer atmosphere would have enveloped its smaller companion. The smaller stars, spiraling inward through this diffuse envelope, would have acted like a cosmic egg beater, churning the gas and triggering the star's rhythmic pulsing. The gravitational forces from this stellar dance could have also funneled the dying star's final breaths into those 2 powerful polar jets, sculpting the chaotic outflow into the precise, artistic form we see today. An alternative idea suggests that the star's own powerful magnetic field, behaving like an invisible sculptor's tool, could have channeled the outflowing gas into these concentric rings and jets. Whatever the true cause, the Cat's Eye Nebula is more than a planetary nebula. It is a cosmic fossil that preserves the turbulent, final millennia of a star's life with an almost unbelievable clarity. It forces us to ask if the most beautiful deaths in the universe require a hidden partner, a silent collaborator in the creation of celestial art. The intricate artistry of the Cat's Eye gives way to a nebula that feels almost brutally modern in its design. NGC 7027 is a cosmic construction site, a young and exceptionally dense planetary nebula that looks more like a rectangular jewel box shattered from within. Its shape is not the gentle symmetry of an hourglass or the layered shells of an onion, but a sharp, irregular form bristling with activity. Intricate structures of glowing gas, including powerful jets and expanding bubbles, are all contained within a sharply defined boundary, as if the entire chaotic event is being observed just moments after it began. This is precisely what makes it so valuable to astronomers. NGC 7027 is not a finished masterpiece. It is a work in progress, allowing us to watch a star's death in what amounts to real time. We are witnessing the transformation of a star into a nebula over a period of mere centuries, a blink of an eye in cosmic terms. This rapid evolution lets us see the raw, unfiltered physics of stellar death, from the initial expulsion of gas to the fierce stellar winds that carve it into complex shapes. Within its glowing, turbulent shells, scientists have made a landmark discovery: the presence of helium hydride. This simple molecule is believed to be the very first type of molecular bond to have formed in the early universe. Detecting it here is like finding a primordial fossil preserved in the aftermath of a modern explosion. It confirms a key piece of our cosmic chemistry models and suggests that the violent death of stars like this one are the crucibles where the basic ingredients for the next generation of cosmic structures are forged. NGC 7027 is more than a nebula. It is a time capsule and a laboratory, offering a frantic, fast-forwarded look at the creation of complexity from the ashes of a single star. From the chaotic construction site of a young nebula, we find a cosmic apparition that has settled into a hauntingly serene form. NGC 3242 glows with an unearthly light, a perfect oval of greenish-blue gas that has earned it the name the Ghost of Jupiter. This is the ghostly afterimage of a star that was once much like our own Sun, now in its final, brilliant act. The nebula's most prominent feature is its intensely bright inner shell, a sharply defined ellipse that seems to hover in the void. This inner region shines with a high surface brightness that makes it a jewel in the eyepiece of any amateur astronomer. A small but fiercely luminous cloud that can even be glimpsed from light-polluted cities. But the ghost has more than one layer. Extending far beyond this bright core are vast, diaphanous halos of fainter gas. These outer shells are the star's earlier, slower breaths, material ejected tens of thousands of years before the inner nebula was formed. We are seeing the star's entire death sequence laid out before us, from its first gentle sighs to its final, forceful exhalation. The process that creates this ethereal, layered appearance is a story of increasing violence. As the star exhausted its nuclear fuel, it first swelled into a red giant and gently shed its outer layers in a slow, steady stellar wind. Then, in its final death throes, the exposed stellar core, now a white dwarf, heated to incredible temperatures. This unleashed a much faster, more powerful wind that slammed into the slower-moving gas from the earlier phase. The collision compressed and energized that material, lighting it up into the bright, oval inner ring we see today. The Ghost of Jupiter is not a single event, but a multi-stage farewell, a celestial echo of a star's life that grows fainter and more expansive with each passing millennium. That ghostly farewell is just one way a star can end its life. Another, known as NGC 2392, presents a face we can almost recognize. The Eskimo Nebula gazes out from the void, its appearance so uncannily human that it earned its nickname centuries ago. We see a bright, round central face surrounded by a faint, complex halo of gas that looks just like a furry Parker hood. This cosmic portrait is actually a detailed fossil record of a star's death, captured in two distinct acts. The brilliant inner face is a fast wind of hot gas blown from the exposed, intensely hot core of the star. This expanding bubble is slamming into the outer hood, which is made of material the star ejected much earlier during its red giant phase. The collision between these two layers of gas illuminates the entire structure, creating the illusion of a face peering from deep space. But the true strangeness lies in the details of that furry hood. The outer shell is not a smooth cloud. It is filled with hundreds of unusual comet-shaped knots of gas. Each of these knots has a bright, glowing head and a long, faint tail streaming directly away from the central star, like a school of cosmic fish all pointing radially outward. What force could create such perfect, organized patterns in the chaos of an explosion? The answer is a powerful stellar wind and intense radiation. The central star, now a white dwarf, is blasting its surroundings with ultraviolet light and a torrent of fast-moving particles. This radiation erodes the denser clumps of gas in the outer shell, sculpting them into these teardrop shapes and causing their tails to glow as they are blown backward. The Eskimo Nebula is more than a pretty face. It is a dynamic laboratory showing us the ongoing interaction between a dead star's corpse and the ghost of its former self. It reveals how the final stages of stellar death can create intricate, almost lifelike structures, a beautiful and complex farewell written across the sky. But even a star's complex farewell is a local event compared to the vast creative furnaces that build entire star systems. NGC 281 is a churning cloud of cosmic gas and dust, a region so vast and bright it has earned the playful name the Pac-Man Nebula for its uncanny resemblance to the video game character gobbling up the sky. This is not the ghost of a dead star, but a vibrant stellar nursery, a place where new suns are actively being born. The entire nebula glows with a fierce pinkish-red light, a color that signals the presence of energized hydrogen gas. But the power for this cosmic light show does not come from within the cloud itself. It is provided by a brilliant young star cluster known as IC 1590, which is embedded deep within the nebula's heart. The most massive stars in this cluster are true behemoths, burning ferociously hot and bright. They flood their surroundings with an intense torrent of ultraviolet radiation, which strips electrons from the surrounding hydrogen atoms and causes the vast cloud to fluoresce, just like a colossal neon sign. This same radiation is also violently sculpting the nebula, blowing away the gas and dust and carving out the vast cavity that gives the Pac-Man its distinctive, gaping mouth. Scattered throughout the glowing gas, you can find dark, compact blotches that seem to absorb the light. These are not empty voids, but Bok globules, dense knots of gas and dust so thick they block the brilliant emission behind them. Each one of these cosmic cocoons is a potential star in the making, a collapsing pocket of material where gravity is fighting to pull matter together into a new sun. Some of these globules may even be giving birth to solar systems of their own. The Pac-Man Nebula presents a snapshot of the continuous cycle of stellar life and death. The same massive stars whose light illuminates the nursery are also destroying it, their radiation eroding the very cloud that gave them birth. And within the dark, dusty remnants, the next generation of stars is already beginning to form, a cycle of creation and destruction on a scale so vast it defies comprehension. Yet even the most vibrant stellar nurseries can hold pockets of absolute nothingness. NGC 1999 is a reflection nebula, a cosmic cloud that does not generate its own light but simply reflects the brilliant starlight of a young, hot sun embedded within it. This particular cloud glows with a soft, ethereal blue light, like a celestial street lamp illuminating a patch of interstellar fog. But at its heart lies a feature that baffled astronomers for years, a vast and perfectly dark keyhole-shaped patch that seemed to be a dense, light-absorbing blob of dust. Then the Hubble Space Telescope took a closer look, and the mystery deepened immeasurably. That dark keyhole was not a dense cloud at all. It was a void, a truly empty region of space, a hole punched straight through the glowing nebula. How could a cloud of gas and dust contain a hole of pure nothingness? The culprit appears to be the nebula's own central star, a volatile infant named V380 Orionis. This newborn star is a tempestuous object prone to violent outbursts and fierce stellar winds. Astronomers theorize that in its energetic youth, the star unleashed powerful jets of material, spewing them from its polar regions at nearly the speed of light. These jets, combined with a ferocious, ongoing stellar wind, likely acted like a cosmic blowtorch, carving a vast cavity through the surrounding cloud of gas and dust. They physically pushed the nebular material aside, creating the empty keyhole we observe today. It is a permanent scar from the star's most violent tantrum, a hollow space that will never be refilled. This discovery fundamentally changed our understanding. It proved that not all dark patches in the cosmos are dense clouds. Some are simply windows into the empty space beyond, created by the raw, unbridled power of stellar birth. The keyhole in NGC 1999 is a reminder that creation and destruction are two sides of the same coin, and that even the act of lighting up a nebula can involve violently blasting a part of it into nothing. But this celestial keyhole is a tiny window compared to the immense pillars that form entire stellar nurseries. NGC 2264 is a sprawling cosmic celebration, a region so festive it has been named the Christmas Tree Cluster. A congregation of brilliant, young, hot blue-white stars is arranged by a trick of perspective into a perfect triangular shape, complete with a bright star at its apex that shines like a celestial tree topper. These are stellar infants burning with a fierce blue light that floods the surrounding space with intense ultraviolet radiation. This energetic glow illuminates vast clouds of hydrogen gas, causing them to fluoresce with a deep red color that wraps around the cluster like a sparkling holiday garland. The entire scene is a dynamic interplay of light and shadow, of creation and erosion. Yet within this brilliant, energetic environment stands a monument of profound darkness. Just off to the side of the glittering tree looms the Cone Nebula, a massive, dark pillar of cold molecular gas and dust that rises from the glowing cloud like a colossal spearhead. It is not a hole like the keyhole in NGC 1999, but a dense, physical structure, a cosmic mountain resisting the storm. The same fierce starlight that paints the surrounding gas red is actively destroying this pillar. The radiation and stellar winds from the hot young stars are slowly boiling away the Cone Nebula from the top down, stripping its material and blowing it out into space. This process, called photoevaporation, creates the nebula's distinct pointed shape, as the more diffuse gas at its edges is eroded away first, leaving the densest core to stand defiant. And it is within this dense, protected core that the true magic is happening. The very tip of the Cone Nebula is not a place of death, but one of intense creation. The immense pressure from the surrounding radiation is actually compressing the gas and dust at the pillar's head, triggering gravitational collapse. Deep inside this dark, dusty shroud, new protostars are igniting, their faint warmth hidden from our view but detectable to infrared telescopes. This pillar is a stellar nursery within a nursery, a shielded cradle where the next generation of stars is being born even as their older siblings work to tear the structure down. The entire region is a single, breathtaking snapshot of the stellar life cycle, from the brilliant young stars lighting up the party to the dark, quiet pillars where the next generation is already beginning to stir. This cosmic bubble is a telltale sign of a star in its final, frantic race against time. NGC 6888, the Crescent Nebula, is a glowing shell of gas sculpted by one of the most extreme and short-lived types of stars in the universe. At its heart lies WR136, a ferocious wolf-rayet star. This is not a gentle giant, but a stellar heavyweight that has burned through its nuclear fuel with reckless speed, shedding its own mass in a continuous hurricane-force wind. The star blows this material outward at a staggering speed of nearly 4 million miles per hour. The nebula we see is not a simple, expanding bubble, but the intricate result of a cosmic collision between two different eras of the star's life. The fast, modern wind from the Wolf-Rayet star is slamming into a slower, denser wind of gas that the star ejected tens of thousands of years earlier, when it was a more stable red supergiant. This collision is like a supersonic freight train plowing into a dense fog. The impact compresses the older gas, heating it to extreme temperatures and causing it to glow with the intense red light of energized hydrogen. This violent interaction creates the nebula's complex filamentary structure, a delicate-looking web of luminous gas that is actually the shock front of a continuous high-energy explosion. The entire structure is a temporary monument, a brilliant but fleeting farewell. The central Wolf-Rayet star is living on borrowed time, destined to explode as a supernova in a cosmic flash. When it does, the beautiful, fragile crescent will be utterly obliterated, consumed by the final, cataclysmic fire of the star that gave it birth. That beautiful, fragile crescent is the last gasp of a star in its final moments, but another cosmic bubble tells the story of a star in its prime. NGC 7635, the Bubble Nebula, is an almost impossibly perfect sphere of glowing gas, looking as if a cosmic child blew a shimmering soap bubble into the depths of space. This delicate-looking structure is not fragile at all. It is the result of a ferocious, continuous output of energy. At its heart lies a star known as SO20575, a massive, intensely hot O-type star that burns with a brilliant blue-white light. This stellar powerhouse is unleashing a hurricane-force stellar wind, blowing its own outer atmosphere into space at speeds exceeding 4 million miles per hour. This torrent of particles is plowing directly into a vast, cold, and dense molecular cloud that surrounds the star. The bubble we see is the shock front where this incredibly fast wind collides with the slower-moving material of the cloud, compressing and heating the gas until it glows with a soft, ethereal light. The entire sphere is a dynamic boundary, a cosmic battle between the star's relentless outward push and the resistance of the interstellar environment. This creates a fascinating surface texture on the bubble itself. The nebula is not a featureless shell. Its surface is mottled with intricate patterns of light and shadow. You can see regions of different density where thicker knots of the molecular cloud resist the expansion more stubbornly, while thinner areas are easily swept aside. This gives the entire structure the appearance of drifting through space, like a ship plowing through a choppy sea of gas and dust. The star itself is dramatically off-center within its own bubble, a clear sign of the uneven nature of the cloud it is expanding into. One side of the bubble is expanding rapidly into a lower density region, while the other side is held back by a much denser wall of cosmic material. This perfect sphere is therefore a testament to both immense power and delicate balance, a transient celestial sculpture that will last only as long as the star has the strength to keep blowing. But the perfect sphere of the Bubble Nebula is a gentle puff compared to the cosmic inferno of NGC 3372, the Carina Nebula. This is not a single object but a sprawling stellar metropolis, a vast cloud of glowing gas and dust so large it could swallow our entire local stellar neighborhood. Within its turbulent heart, stars are born in frantic clusters and die in spectacular supernova. But one star dominates this chaotic landscape with its sheer, terrifying instability. Eta Carinae is a stellar behemoth, a hypergiant so massive and volatile that it defies all conventional ideas of how a star should behave. In the 1840s, this star did something unprecedented. It erupted not in a final supernova, but in a colossal outburst that astronomers call the Great Eruption. For over a decade, Eta Carinae became the second brightest star in the entire night sky, outshone only by Sirius, a testament to the staggering amount of energy it released. It ejected more than 10 times the mass of our Sun into space, not in a spherical shell, but in two opposing lobes. This expelled material formed a new, smaller nebula within the larger one, a structure known as the Homunculus Nebula. The name means little human, and from our perspective, its shape is eerily organic, resembling a vast cosmic lung or a pair of intertwined lobes. This bipolar cloud is not static. It is still expanding outwards from the star at phenomenal speeds, a permanent and growing monument to that single violent event. The homunculus is a time capsule, preserving the chemical and physical conditions of that eruption, allowing us to study the tantrum of a star that, against all odds, somehow survived its own self-destruction. Today, Eta Carinii remains a ticking time bomb, a star so unstable that its final, true supernova explosion could happen at any moment, an event that would outshine the combined light of every star in our own galaxy. Even within the Carina Nebula's grand chaos, smaller, more intricate structures hide in plain sight. Rising from the gas like a celestial fortress, the Mystic Mountain stands as a monument to simultaneous creation and destruction. This towering pillar of cold gas and cosmic dust stretches over 3 light-years high, a skyscraper on an interstellar scale. It is not a solid structure, but a dense, turbulent cloud being actively sculpted by its environment. From the top of the pillar, you can see a fierce stream of radiation pouring outward, a stellar wind from nearby newborn massive stars that are not visible in this frame. This relentless energy is boiling the pillar away from its tip, evaporating the gas and dust and blowing it out into space. This process, called photoevaporation, carves the pillar into its dramatic, twisting shape, etching away the softer material and leaving behind the most resilient spines. Yet within this apparent destruction lies the spark of creation. The same radiation that is eroding the pillar is also compressing it. The intense pressure from the stellar wind is squeezing the gas and dust at the pillar's core, triggering gravitational collapse. Deep inside these dark, dusty columns, new protostars are igniting. The Mystic Mountain is not just a beautiful ruin, it is a stellar nursery under siege, where stars are fighting to be born even as their future home is being systematically torn apart around them. Scattered throughout the nebula, often silhouetted against the glowing gas, are countless dark, compact blobs known as Bok globules. These are not empty holes, but the opposite, incredibly dense knots of molecular gas and dust. They are so thick and cold that their gravity holds them together, and they completely block the brilliant light from the nebula behind them. Many of these are what astronomers call globulets, small and isolated versions of the larger pillars. While the massive pillars like the Mystic Mountain may form clusters of suns, these smaller globules are the likely birthplaces of individual low-mass stars. Some are even thought to be incubators for brown dwarfs, strange objects often called failed stars. Brown dwarfs are not massive enough to ignite sustained hydrogen fusion in their cores, and so they occupy a mysterious middle ground between giant planets and true stars. They glow faintly with the residual heat of their formation and slowly cool over billions of years. These dark, drifting globules are the cosmic cradles for these faint, enigmatic objects. The Carina Nebula thus presents a complete picture of stellar life, from the terrifying instability of giants like Eta Carinii to the majestic, eroding pillars forming star clusters, down to these tiny, dark specks that may be quietly nurturing solitary, faint stars and planetary systems all their own. It is a single ecosystem operating on every scale imaginable. This cosmic blink is no digital glitch, but a quirk of human perception. NGC 6826, the blinking planetary nebula, plays a strange trick on anyone who views it through a telescope. You look directly at it, and you see a brilliant, unwavering star set against the blackness of space. The faint, glowing cloud around it seems to vanish completely. Then you shift your gaze just slightly to the side, and the nebula blinks into existence, a beautiful greenish oval of gas surrounding the central pinprick of light. Look back directly and it is gone again. This eerie effect is not happening out in space, but inside your own eye. The central star is a fiercely hot white dwarf, and its light is so intensely concentrated that it overwhelms the most sensitive part of your retina, the fovea, which is responsible for our sharp central vision. When you stare straight at the star, the fovea is dazzled, rendering the much fainter, more diffuse light of the surrounding nebula virtually invisible. But when you use averted vision, you are utilizing the more light-sensitive rod cells in the periphery of your retina. These cells are far better at detecting faint, extended objects in low-light conditions. By looking slightly away, you sidestep the blinding glare of the central star, allowing your eye to gather the subtle glow of the nebula itself. The nebula is always there, of course, a shell of gas ejected by the dying star. But its visibility is entirely dependent on how we choose to look at it. A perfect reminder that our perception of the cosmos is filtered through the very human limitations of our own biology. Far from a simple blinking trick of the eye, the next object offers an illusion of celestial identity. NGC 7009 resembles the ringed planet Saturn so perfectly it earned the name the Saturn Nebula. At first glance, a small telescope reveals a bright, oval central cloud flanked on either side by two distinct, point-like protrusions. These extensions, known to astronomers as ansi, look just like Saturn's rings seen nearly edge-on. But this is no planet, it is the ghost of a star, and those ansi are not solid rings at all. They are high-speed jets of gas, fierce supersonic winds blasted from the poles of the central white dwarf star. These collimated outflows are punching their way through the slower-moving shell of the main nebula, creating the illusion of handles on a cosmic cup. The structure of the nebula itself is a complex fossil record. The brightest inner oval is a shell of gas ejected most recently, glowing fiercely under the intense ultraviolet radiation of the central stellar remnant. Surrounding this brilliant core is a much larger, fainter, and elongated outer shell. This delicate halo is the star's earlier, slower breath, material it gently puffed away during its red giant phase tens of thousands of years before the final cataclysm. We are seeing two distinct eras of mass loss, two separate farewells preserved in a single, glowing structure. The entire system is a testament to the precision of stellar death. The central star did not explode randomly, but focused its final, most energetic outflows into two narrow, opposing jets. This intricate layering and focused ejection suggests a death overseen by a powerful, invisible hand, perhaps the star's own intense magnetic fields or the gravitational influence of an unseen companion star, sculpting the chaotic process into a recognizable, almost planetary form. The Saturn Nebula's intricate layers give way to another cosmic jewel that appears deceptively simple at first glance. NGC 7662 shines like a single, brilliant blue-green marble tossed into the void, earning it the name the Blue Snowball. Through a small telescope, it is a perfect, featureless disk of ethereal light, a stark and beautiful contrast to the surrounding stars. But this serene appearance is an illusion of distance and limited perception. When viewed with the powerful resolution of the Hubble Space Telescope, the snowball reveals a far more complex and turbulent soul. Its core is not a uniform glow, but a bright, elongated oval ring of gas like a cosmic smoke ring. Extending from the ends of this oval are faint, jet-like structures, the same ansi seen in the Saturn Nebula, hinting at powerful outflows from the central star. And enveloping the entire brilliant structure is a vast, faint, and perfectly spherical halo of gas, a ghostly remnant of the star's first, gentle size thousands of years before its final death throes. This layered structure is a fossilized timeline of the star's demise. The chemical composition of this cosmic artifact is what gives it that unforgettable blue-green hue. The intense ultraviolet radiation from the central white dwarf star, a stellar corpse with a surface temperature soaring over 100,000 degrees, bombards the surrounding nebula. This energy excites the atoms of oxygen within the gas, causing them to glow with a brilliant greenish-blue light that dominates our view. Other elements are present, including hydrogen and nitrogen, but it is this energized oxygen that paints the snowball its characteristic color. The nebula's remarkable symmetry, from its inner oval to its outer spherical halo, points to a death process of incredible precision. How does a star manage to die with such geometric control? The answer likely lies in the same forces that shaped its cousins, perhaps a powerful magnetic field channeling the outflowing gas or the gravitational tug of a binary companion star that helped sculpt the chaos into this layered, luminous masterpiece. The blue snowball is a reminder that cosmic beauty often hides profound complexity, a simple disk of light that, upon closer inspection, contains the entire structured history of a star's final farewell. The serene symmetry of the blue snowball is a beautiful lie, a final artistic statement from a dying star. But the universe holds other forms of perfection, ones built on a scale so vast they defy our very perspective. Drifting through the constellation Coma Berenices, NGC 4565 presents itself as a celestial splinter, a sliver of light so impossibly thin it has earned the name the Needle Galaxy. We are not looking at this spiral galaxy face-on with its arms elegantly splayed out. We are viewing it precisely from the side, a perfect edge on perspective that reveals its true razor-thin profile. This is not a small object, it is a colossal island of stars, likely larger than our own Milky Way, but from our vantage point it is compressed into a breathtaking line of light. The central bulge, the galaxy's dense core, glows with the soft golden light of billions of ancient stars, forming a distinct ellipsoid at the needle's center. But the most striking feature is the dark, sharp lane of cosmic dust that splits the galaxy perfectly in two along its entire length. This is not an empty gap, but a thick band of cold gas and dust, the raw material for future stars, which obscures the brilliant starlight from the galaxy's thin disk. This single, dark line tells us everything about the structure of a spiral galaxy. It confirms that the vast majority of a galaxy's stars, gas, and dust are confined to an incredibly flat plane, a disk so thin that when viewed from the side, it appears as little more than a crack in the cosmos. The Needle Galaxy is a cosmic lesson in orientation. It shows us that the majestic spirals we so often admire are actually these profoundly flat structures, and that their apparent grandeur is entirely dependent on our point of view. This realization leads to a profound and humbling thought. How many other needle galaxies are out there, completely invisible to our surveys because their thin edge is pointed directly at us, hiding their light in a line too faint for our telescopes to easily detect? We see the grand, face-on spirals clearly, but the universe may be filled with countless more of these cosmic splinters, their vast populations of stars and planets hidden from our view simply by the random chance of their alignment. NGC 4565 is a reminder that the cosmos is shaped by perspective, and that for every brilliant, sprawling galaxy we can study, there may be a dozen more needles in the cosmic haystack waiting to be found. Yet the Needle Galaxy is not the universe's only cosmic splinter. Another, far more subtle sliver of light drifts nearby, a galaxy so faint and delicate it appears to be spun from pure moonlight. NGC 4244, the Silver Needle Galaxy, presents a similar edge on view, but with a profound and telling difference. Where NGC 4565 shows a bright golden core bulging at its center, the Silver Needle is ghostly uniform, a razor-thin ribbon of starlight with no central bulge to speak of. It is a super-thin galaxy, its stars distributed in an almost impossibly flat disk. This lack of a prominent bulge makes it far more difficult to see, a low-surface brightness object that requires dark skies and patience to observe. Its dim, silvery glow is not a sign of small size, but of a different galactic architecture altogether. Why would one spiral galaxy build a dense, central hub of ancient stars while another remains perfectly flat? The answer lies in a quieter, more serene life. Galaxies like the Silver Needle are thought to have avoided violent mergers and collisions for billions of years. Without the gravitational chaos of such cosmic crashes to stir up their stars and puff up their central regions, their disks have remained calm, thin, and orderly. This pristine state makes them perfect natural laboratories. By studying these super-thin galaxies, astronomers can peer back into the conditions of the early universe, understanding how pristine disks of gas first collapsed to form stars without the complicating effects of later galactic violence. But such a delicate structure presents its own cosmic puzzle. A disk this thin should be incredibly fragile, vulnerable to any passing gravitational tug that could warp it or tear it apart. The fact that it holds its perfect form means something invisible must be holding it together. This is where the mysterious hand of dark matter enters the story. Astronomers believe a massive, invisible halo of this unknown substance envelops the galaxy. This dark matter halo provides a stabilizing gravitational scaffold, a cosmic framework that keeps the thin disk of stars rigid and flat against the tides of intergalactic space. The Silver Needle Galaxy, in its serene subtlety, is more than just a beautiful sliver of light. It is critical evidence for the invisible architecture of the cosmos, a whisper-thin disk of stars that is held steady by the profound, unseen mass of dark matter. Soaring through the void with a sleek, lens-shaped profile, NGC 2683 perfectly mimics a classic flying saucer. This spiral galaxy presents a flawless edge on view, its form dominated by a brilliant, elongated core of golden yellow light. This central hub glows with the combined radiance of countless ancient stars, creating the saucer's distinctive central dome. The galaxy's spiral arms are wound so tightly and compressed so flat by our perspective that they blend into a seamless, luminous disk, completing the uncanny illusion of a silent cosmic craft. For astrophotographers, this clean, geometric shape is a prized target. Its sharp, defined edges and lack of obscuring dust lanes make it appear almost too perfect, like a celestial model suspended against the black velvet of space. But this serene appearance hides a hive of frantic activity. Within that thin, sleek disk, the galaxy is experiencing a remarkably high rate of star formation. Vast clouds of hydrogen gas are collapsing under their own gravity, igniting new stellar nurseries at a pace that puts our own more sedate Milky Way to shame. This burst of creation is likely fueled by the galaxy's dynamic structure, its density waves compressing gas efficiently to spark the fires of new suns. The UFO galaxy is a beautiful paradox, a vision of calm, geometric perfection that simultaneously hums with the vibrant, chaotic energy of birth, a silent saucer carrying the future of an entire star system within its slender form. But the sleek design of a cosmic saucer is just one way a galaxy can organize its light. NGC 4736, known as M94, presents a face of almost impossible order, a spiral galaxy that looks like a cosmic eye staring out from the void. Its most arresting feature is a brilliant, sharp ring of blue-white light that wraps tightly around its golden core. This is not a gentle glow, but a ferocious circle of star formation, a starburst ring where new suns are being born at a frantic, almost unsustainable pace. The intense blue color is the unmistakable signature of countless massive, young, and incredibly hot stars, burning their nuclear fuel with a fierce urgency. This ring is so bright and so compact that it outshines much of the rest of the galaxy, creating a dazzling bullseye effect. Yet, if you look beyond this brilliant inner ring, a second, much wider structure emerges. A fainter, more diffuse outer ring connects to the galaxy's faint spiral arms, forming a second, larger circle that appears to ripple outward from the central core. This gives M94 the appearance of a double-ringed galaxy, a rare and striking configuration. What cosmic force could create such a perfectly defined circle of fire within a galaxy? The leading theory points to a resonance, a gravitational rhythm that moves through the galactic disk. Much like the regular orbits of moons that create gaps in a planet's rings, the collective gravitational pull of the stars and the central bulge can create standing waves in the galaxy's disk. These waves act like a traffic jam for stars and gas, piling up material at specific distances from the center. The inner starburst ring of M94 is thought to sit precisely at one of these resonant points, where gas clouds are compressed so violently that they collapse en masse, igniting a firestorm of star birth all at once. Another possibility is that the galaxy experienced a close encounter with a smaller neighbor in its distant past. The gravitational disturbance from this flyby could have sent a density wave rushing inward, gathering gas and dust into that perfect circle and triggering the starburst we see today. This would make the brilliant ring a temporary phenomenon, a brilliant but fleeting blaze of youth that will eventually consume all the available fuel and fade, leaving behind a more sedate and ordinary spiral. M94 challenges our ideas of how star formation works, showing us that it can be focused into precise, geometric patterns by the invisible hand of gravity, creating a celestial eye that watches us with a ring of pure, newborn fire. A galaxy's core can sometimes ignite with the sudden fury of a cosmic firecracker. NGC 4314 is a barred spiral galaxy, a system with a long, bright central bar of stars, but its true secret lies deep within its heart. There, wrapped tightly around the very center, is a brilliant, compact ring of newborn stars, shining with an intense blue-white light. This is a circumnuclear starburst ring, a place where star formation is not just happening, but erupting in a violent, concentrated burst. The entire ring is a stellar nursery on overdrive, a frantic celebration of birth occurring perilously close to the galaxy's core. This is not a slow, steady process, but a recent and spectacular firework display frozen in time, creating massive, luminous stars that burn hot and fast. How could such a ferocious event be happening right next to the gravitational dominance of the galactic center, a region often thought to be a quieter retirement home for older stars? The answer lies in the galaxy's unique architecture. That long, central bar of stars acts as a cosmic fuel line. As the bar rotates, its immense gravitational field pulls on clouds of cold gas and dust from the galaxy's outer regions. This interstellar material doesn't just drift inward slowly, it gets funneled, channeled directly down the bar like a river flowing toward a drain. All this gas piles up in a dense, swirling reservoir just outside the very center of the galaxy. When this accumulated gas reaches a critical density, it collapses under its own weight, and the result is a chain reaction of star birth that lights up in a perfect circular ring. This ring marks the precise zone where the inward rush of gas is finally halted and compressed, a standing wave of creation in the galactic disk. It is a brilliant but temporary phenomenon. The very stars it creates are so massive that their fierce radiation and eventual supernova explosions will soon blow the remaining gas and dust away, shutting down the starburst almost as quickly as it began. This makes NGC 4314 a fleeting snapshot of a self-regulating cycle, a galaxy that built a pipeline to its own core, ignited a brilliant ring of fire, and will ultimately be the reason that fire goes out. Two spiral galaxies are locked in a graceful, destructive dance, their long tails stretching across the void like a pair of cosmic mice fleeing the scene. NGC 4676, the Mice Galaxies, are a snapshot of a merger caught in its most dramatic phase. Unlike the chaotic wreckage of NGC 520, the mice exhibit a clearer, more drawn-out sequence of gravitational interaction. Their two spiral disks have already made their first close pass, and now the immense tidal forces between them have pulled enormous streams of stars, gas, and dust out into intergalactic space. These are the iconic tails, each one stretching for hundreds of thousands of light years, far longer than the parent galaxies themselves. They are not solid structures, but rivers of individual stars and vast clouds of material, forever lost to the galaxies that birthed them. Yet within this grand-scale destruction, new life ignites. The same gravitational forces that are tearing the galaxies apart are also violently compressing the gas within them. Throughout their bodies, and especially along the length of their tidal tails, pockets of dense gas collapse, triggering brilliant blue bursts of star formation. These stellar nurseries light up the chaos, creating a spectacle of both ruin and creation happening simultaneously. The dance of the mice is a slow one, unfolding over hundreds of millions of years. They will continue to swing past each other, their gravitational embrace pulling them back for another pass, and then another, each time losing more of their original shape and identity. Their spiral arms, once pristine and distinct, are now hopelessly tangled and distorted. This is the intermediate stage between separate galaxies and a single merged entity. Eventually, after numerous close encounters, their orbits will decay and they will settle into the final act, swirling together to form a new, larger galaxy, most likely a featureless elliptical. This celestial choreography provides a clear window into the future of our own local group. The mice show us the specific steps that lead from a close pass to a full merger, a process that our Milky Way and the Andromeda Galaxy are destined to begin in a few billion years. We are not just watching two distant mice, we are seeing a preview of our own galactic fate, a beautiful and violent ballet that ends with the birth of something entirely new from the scattered pieces of the old. These two galaxies have taken their final, fateful plunge. NGC 4038 and NGC 4039, known together as the Antennae Galaxies, represent a merger far more advanced than the graceful dance of the mice. Their long, sweeping tidal tails, which give the pair its insect-like name, are the most spectacular ever observed, stretching for hundreds of thousands of light years across the cosmos. These are not mere streams of stars, they are the galactic equivalent of a final, desperate breath, an entire spiral arm's worth of material being permanently stripped away into the endless dark. Within the main bodies of the galaxies, the chaos is absolute. The two cores, once the separate hearts of distinct spiral systems, are now approaching each other for their last, irreversible collision. This is not a near miss, it is a direct hit, and the gravitational shockwaves are tearing both galaxies apart from the inside out. The result is a firestorm of creation. Enormous clouds of hydrogen gas, wrenched from their peaceful orbits, are slamming into one another at phenomenal speeds. This violent compression triggers a ferocious starburst, a region where stars are being born at a rate hundreds of times faster than in our own tranquil Milky Way. The entire central region glows with the fierce blue-white light of countless newborn massive stars, each one burning with a furious, temporary intensity. Scattered throughout this maelstrom are brilliant, compact knots of light, each one a superstar cluster containing up to 1 million young suns bound together by their mutual gravity. These are the likely building blocks of the new galaxy's future globular clusters, ancient celestial fossils in the making. We are witnessing the formation of a permanent, spherical halo of stars around a galaxy that does not yet fully exist. This entire cataclysm provides the clearest local blueprint for the final stages of a major galactic merger. The antennae show us what happens after the first pass, after the tidal tails have been drawn out, when the two systems commit to their final union. The elegant spiral structures are gone, consumed by the violence of their own interaction. What will be left after a few 100 million more years is a single, massive elliptical galaxy, a quiet giant born from this spectacularly violent beginning. This is the ultimate fate of all such cosmic collisions, a beautiful and terrifying reminder that the universe's most enduring structures are often forged in its most destructive fires. From chaotic mergers to serene rings, these 28 objects reveal a universe brimming with impossible beauty and violent wonder. We have journeyed past galaxies that stare back with a flickering eye, witnessed stars die in intricate, layered farewells, and found delicate threads of gas miraculously surviving in a superheated inferno. Each entry in this cosmic catalogue is more than a point of light, it is a profound question. How can a galaxy form a perfect circle of fire, or a star's final breath sculpt a butterfly from glowing gas? These are not mere anomalies, they are the fundamental forces of physics and gravity writing their story across the void, one strange and spectacular object at a time. They challenge our assumptions about order and chaos, revealing that creation and destruction are forever intertwined. Every one of these cosmic wonders represents a different chapter in the grand story of the universe, from its tumultuous beginnings to the serene deaths of its stars. So we have to ask, which of these 28 strange objects captured your imagination the most? Was it the cosmic car crash of NGC 520, the haunting symmetry of Hoag's object, or the volatile fury of Eta Carinii? We would love to hear your thoughts in the comments, and if this journey through the NGC has left you curious for more deep space mysteries, be sure to subscribe for our next exploration into the unknown.